Hi, today we are in the experimental laboratory of chemistry in Federico Villarreal National University. We are going to talk about crude oil fractions. But what is the first question? How can oil be separated into different fractions? Common sense says you should have to vary it up. Thus, as the temperature rises, compounds with fewer carbon atoms in their molecules are easily released. Then the liquid compounds vaporize and also separate. And so, successively, the different fractions are obtained. In other refineries, these separations are carried out in the fractionating or primary distillation towers. For example, one of the most important refineries, and the first one here in Peru, is called Refinery. Its capacity is about 65,000 liters of petroleum every day. And now I'm going to explain you how to obtain crude oil fractions. As you are now aware, large hydrocarbons have high boiling points and so are removed at the bottom of the fractionating column. Smaller molecules condense higher up to column. So we will now take a look at some of common fractions that move down from the fractionated column. Some of the smallest molecules are between 1 and 4 carbons in height. This fraction has such a low boiling point that this is still as a game when it is removed from the every top of the fractionated column. So this fraction is now a refinery gas of bottle gas. Bottle gas because it can be stored in bottles. Under high pressure, you will have spent bottles of propane or butane running barrels. For example, the commercial gas that you use in your house contains a mix of gas. For example, propane and butane. Talk about the petrol. Petrol is between 5 to 7 carbon in height. It is still a fraction of small chain hydrocarbons, and therefore these evaporate at a low temperature and are easily ignited. This makes it very useful. So, as a fuel in the internal combustion engine of a car is naphtha. Naphtha is not such a useful fuel but is a valuable source of organic molecules and can be corroded. To make more fuel fuels and alkanes, alkanes can be turned into polymers and polymers can be bottles and other things that we know.
So continue with the exposition of the fraction of the oil crude. Now we're going to talk about the kerosene. The kerosene, the range of degrees is 160 and 250. So the kerosene has an important use as a fuel for jet engines, in aircraft, and even in some rockets. Kerosene is also called paraffin in some part of the world and is a common fuel bar in paraffin, and also you can use the kerosene in the lamps used for lighting. Continue with the explication. Now is diesel. The diesel has a range of 250 and 350 degrees. So it's a common fuel in cars, vans and lorries. It's not as volatile as petrol, and instead of sparking emission like petrol, it ignites under compression. So at the bottom we have the residue, that is the continue of diesel. So here we can find the fuel oil that's used as a fuel in power station and ships, lubricated oil which sticks to surfaces and reduce friction and protect from rust. Also we have the waxes, which along with the oils can be used for polishing surfaces. So, and finally we have the very bottom fraction, that is bitumen. This is the thick black adhesive used on roads, either as the surface finish or combined with the stone chippings to create a solid resistant materials like this. And also it can be used to cover the roof that due to its waterproof properties.
All these fractions are separated from the crude oil mixture. To try explain the importance of crude oil, consider this. There is estimated to be over a billion cars in the world. To be over a billion cars in the world. There are many millions fleet per year, each burning kerosene fuels. Not forgetting the mass of plastic that is made each day for products in their packaging in Canada. Bitumen used to surface in resurface around the world. As you can see, crude oil containing many useful products that just need to be separated.